Hey! Welcome back to Innovative Creator. Oumuamua is so weird I wish it never existed. Oumuamua is back and suddenly heading toward Earth. Oumuamua, the mysterious interstellar object that captured the world's attention on its first visit, is making headlines again. But this time there's a twist. It's on a trajectory that seems to be pointing straight towards Earth. So what could this mean for us? Are we on the brink of an unprecedented encounter with extraterrestrial intelligence? And perhaps most intriguingly, what mysteries might Oumuamua unveil as it draws closer to our planet? Come along as we delve into the resurgence of Oumuamua and the captivating mysteries it brings to our celestial doorstep. In 2017, an extraordinary milestone was achieved in the field of astronomy with the identification of an object named Oumuamua. This remarkable discovery marked the very first observation of an interstellar object passing through our solar system. The impact of this finding is profound. Before Oumuamua, astronomers concentrated their efforts on studying objects within our solar system. Despite this focus, many phenomena within this familiar area remained unexplained. However, the arrival of Oumuamua opened a new field of exploration, giving researchers a unique chance to study a celestial body from beyond our solar system. This discovery has significantly expanded the scope of astronomical research. The arrival of Oumuamua was not just a random event, it was a significant cosmic occurrence that provided a rare opportunity to explore areas previously out of reach. This stirred great excitement among scientists who usually studied the familiar objects in our solar system. Suddenly, they were faced with a mysterious object from the far reaches of interstellar space. Calling this discovery groundbreaking doesn't do it justice. The study of Oumuamua was immensely important for several reasons. First, it gave scientists a rare chance to examine the variety and composition of objects from distant star systems. This was key to gaining deeper insights into the basic building blocks and formation processes of celestial bodies throughout the universe. By carefully studying Oumuamua's composition and structure, researchers sought to uncover important clues about its origin, the conditions it faced during its journey through interstellar space, and the processes that shaped its unique features. What they discovered was astonishing. Through detailed research, scientists gathered a wealth of information about Oumuamua's makeup and characteristics. These findings offered not just a look at a single object, but a wealth of knowledge about the conditions and phenomena influencing distant interstellar objects. Each piece of data collected from Oumuamua's study provided a pathway to a better understanding of the dynamics that govern celestial bodies traveling across the vastness of space. Oumuamua is quite different from the usual asteroids or comets we see in our solar system. It looks like a long rock, almost like a cigar. Typically, comets come from far away in our solar system, like the Kuiper Belt or the Oort cloud. These icy objects are usually made up of frozen gases, water ice, dust, and rocks. Unlike Oumuamua's long shape, comets are more round or irregular in shape, like dirty snowballs with different shapes and surface features. As comets get closer to the Sun, the ice inside them starts to turn into gas, releasing dust particles. This can create a cloud of gas and dust around the comet, sometimes forming a tail that points away from the Sun due to solar wind and radiation pressure. Comets can vary a lot in size, ranging from a few hundred meters to several kilometers in diameter. For example, Halley's Comet, which we often see in the inner solar system, has a nucleus estimated to be around 15 kilometers wide. While some comets might have larger nuclei, they usually have a similar shape and structure. What makes Oumuamua unique is its reddish color, which is different from the usual comets. This color is similar to objects we find in the outer parts of our solar system, suggesting that Oumuamua has a special composition or surface. Despite being close to the Sun during its journey, Oumuamua didn't have a coma, which is a cloud of gas and dust around the nucleus that regular comets have. This absence of a coma tells us that Oumuamua is not like the typical comet we're familiar with, it's something entirely new and different. The behavior of Oumuamua continues to interest scientists because of an unusual occurrence, its acceleration that doesn't follow gravitational rules. This acceleration shows that there are other forces at work besides the Sun's gravity. This intriguing behavior is due to two main reasons: outgassing and solar radiation pressure. Outgassing happens when volatile substances like gases or frozen materials trapped within the surface layers of a space object turn into vapor and get released into space. When a comet gets close to the Sun, the increased heat causes these volatile materials in its core to turn into gas and dust, creating a bright cloud around the core and forming the distinctive tail seen in comets. The fact that Oumuamua shows signs of outgassing suggests that it has similar volatile substances within it, like comets. This outgassing could be pushing Oumuamua, making it deviate from its expected path, which would normally be determined only by gravity. Solar radiation pressure also plays a big role in understanding Oumuamua's behavior. This force comes from sunlight pushing against objects in space. Even though each particle of light, called a photon, has a tiny amount of momentum, when many photons from sunlight hit an object, they can create significant pressure. Because of Oumuamua's long shape and the pressure from sunlight, it could be experiencing a non-gravitational acceleration. The combination of its shape and the constant pressure from sunlight might be causing the observed changes in its path, showing that there are forces at play beyond just gravity. While Oumuamua spins, its brightness changes dramatically by a factor of 10, which is much more than any asteroid or comet we know of in our solar system. Its spin takes about 7.3 hours, showing how much its brightness can vary. This uniqueness highlights how special Oumuamua is. However, figuring out its size is a real challenge. Different studies and observations have given different ideas about how big Oumuamua is, making it hard to pin down its actual size. NASA's Jet Propulsion Laboratory did a study suggesting Oumuamua could be anywhere from 320 feet to 1,440 feet in diameter, hinting that it might be spherical within this size range. On the other hand, NASA's Solar System Exploration Team thinks Oumuamua might be elongated, up to a quarter-mile long and about 10 times longer than it is wide. This means it could be much longer than it is wide. But a recent study disagrees with these estimates, suggesting Oumuamua might be smaller, around 146 feet by 144 feet by 24 feet, much smaller than what was previously thought. Despite these different guesses about its size, one thing remains constant: Oumuamua looks like a cigar, which is a major characteristic that scientists are trying to understand better. To help with this, they're using the Pan-STARRS 1 telescope located in Maui, Hawaii. It is essential for studying Oumuamua and other space objects. This telescope is part of a project involving the University of Hawaii Institute for Astronomy, MIT Lincoln Laboratory, Maui High Performance Computing Center, and Science Applications International Corporation. The project uses advanced cameras and computer systems to continuously scan the sky, identifying moving or changing objects and providing detailed information about them. Since beginning its scientific operations in May 2010, the Pan-STARRS 1 telescope has been instrumental in discoveries like Oumuamua. The Pan-STARRS 1 telescope is particularly well suited for studying objects like Oumuamua due to its unique wide-field optical design. This design allows the telescope to survey a large portion of the sky during its observations, increasing the chances of detecting faint celestial objects that might otherwise go unnoticed. It has an impressive field of view covering 7 square degrees and a powerful 1.4 gigapixel camera. These features enable the telescope to collect extensive data and significantly enhance its accuracy in detecting and tracking celestial bodies, even those with very faint light. Additionally, the strategic location of the Pan-STARRS 1 telescope in Hawaii offers several benefits for studying objects like Oumuamua. The island provides clear, dark skies with minimal light pollution, creating ideal conditions for observation. This environment, combined with the telescope's high sensitivity to faint objects, was crucial in successfully detecting Oumuamua as it passed through our solar system. Oumuamua entered our solar system from the direction of the constellation Lyra, but its exact origin remains unknown. It may have traveled for billions of years across the galaxy before reaching and moving through our solar system. A new study in Nature Astronomy proposes an interesting idea about where Oumuamua comes from. The study suggests that Oumuamua might have broken off from a bigger planet in another solar system, but because of strong gravity from its home star, this planet piece got torn apart. The broken pieces were scattered into space, sending Oumuamua on its journey between stars. After leaving its original solar system, one fascinating thing about Oumuamua is how it sped up unexpectedly while passing through our solar system, a topic that scientists have talked about before. When it first came into our solar system, it was above the plane where planets orbit. It got very close to the Sun, just 0.25 times the distance from Earth to the Sun. After that, it moved below the planet plane. Throughout this trip, Oumuamua kept moving fast, going at about 196,000 miles per hour. The super speed shows how much energy it had during its trip. The fast speed might also be because of how Oumuamua is made. Scientists have learned some interesting things about its structure. Oumuamua has a tough outer layer made of carbon-rich stuff, hardened by cosmic radiation during its long trip between stars. Inside, it's dense with rocks and maybe some metals. But what's unusual is that it doesn't have any water or ice, unlike most comets or icy things we see in our solar system. Also, its surface looks reddish because it's been hit by cosmic rays for millions of years. This long exposure to cosmic radiation changed how Oumuamua looks and made it different from other similar space objects. The discussion about Oumuamua's return has become even more interesting as experts consider the fascinating idea that this space object could be something made by beings from another world. This idea comes from noticing some strange things about Oumuamua that don't fit with what we usually see in space. One big thing is its shape. Instead of being round or irregular like most things in space, Oumuamua looks like a long cigar, much longer than it is wide. This kind of shape is very unusual for celestial objects. Another thing that has made people wonder is how Oumuamua moved into space. Its movements didn't follow the normal patterns we expect from gravity. Some people think it might have been pushed by a different kind of technology or engine, maybe something like a light sail that uses energy from stars to move. This idea suggests that Oumuamua might be a part of a spaceship made by advanced aliens sent on purpose to explore other star systems. What's also strange is that Oumuamua didn't have the tail or gas emissions that we usually see with comets or asteroids. Some people who believe in the idea that Oumuamua comes from aliens think that maybe these aliens are using a kind of propulsion that we don't know about yet, something beyond our current understanding of science.